Hello there. This problem is going to be involved. We're going to solve for x inside this sine function, but we're going to solve for all possible values of x. And to help us out, we're going to start by graphing it. It can always be a little bit challenging figuring out what your period is going to be and just knowing how far to scale this out, because this looks crazy going all the way up to 8 pi. Is that really necessary? But remember that period is 2 pi over b, and our b here is 1/2. So 2 pi over 1/2, that's actually 4 pi. So it takes a while to complete a cycle, twice as long actually. So going out to 8 pi here, it's going to let me see multiple bends in the curve. So that's why we went out that far. All right, so next let's get the midline. That midline is at the square root of 3, which is between 1 and 2. And I think it's closer to 1.7, so we'll just sketch it in there. There's our midline, square root of 3, y equals. And we're going to have an amplitude of 2, so we're going to be able to go up 2 from that one too, so maximum's going to be up there. Oops, this is going to cut into the graph, and minimum's down 1, 2, minimums are going to be over here somewhere. So we're going to have these upper and lower boundaries. Chunk, chunk. Okay, so now to draw the curve. Remembering our Unit 6 stuff, this is a sine wave, so we're going to start on the midline, and we're going to start at pi over 4. So putting in the little tick marks for that pi over 2 throughout there. I actually want halfway between that, so I'm going to start right there. That's my pi over 4. And I'm not going to return one full cycle later is 4 pi. So I don't return there until back over here. Actually, we're going to return in between, and at 8 pi, we'll do another one. So in between these 2 pi later, that's going to be here, again at the midline. Another 2 pi after this one, boom. So there on the midline, 2 pi after that, that gets us forward to that one. And we can actually go backwards from that too. Boom. Now we're going to be going up. Our amplitude is 2. So 1 pi in between these, we're going to hit our maximum. 1 pi in between these, minimum. 1 pi maximum, 1 pi minimum. So our curve, and let's see, if we go backwards 1 pi from this, we're going to be back here at a minimum. So our curve is going to be kind of smooth down there, weaving through these points, so on and so forth. And we want to know where we're equal to the square root of 12. Now the square root of 12 in simplest radical form, that's equal to 2 root 3. So you could take your root 3 length there and effectively double it. If we said it's about 1.7, I think that's going to be around 3.4. So here's our line coming across. It's kind of messy. I should have put it lower. Whoops. That's not what I wanted. Okay, erase that. There we go. So that was a 2 root 3, which we said was about 3.2. So here's our line, y equals 2 root 3. And we see that we're going to have solutions in these different places. That's going to go down, then we'll have some back over on this side too. So there's the visual on all of this. And we're going to now figure out where these points are. Now, because we sketched it, dropping this down is like, I'm not quite sure how much I trust the sketch. Like, is it halfway in between? We're going to go to the algebra now. So rewriting that equation, I'm rewriting the square root of 12, that's 2 root 3, and then I can subtract that root 3 from both sides. So this is looking pretty good at this point. Now we can divide both sides by 2. And doing a substitution in here. So think about this is sine of something, we'll call it u, and that's equal to root 3 over 2. So if you imagine a unit circle, square root of 3 over 2, that's at basically that kind of those highest elevations, root 3 over 2. So that's going to be both at pi over 3 and 2 pi over 3. So that's what u is equal to, both pi over 3 and 2 pi over 3. And if we hadn't gotten such a nice number, we'd have to pull out our calculator and figure out what that is, and then do 180 or pi minus that to get this other one. But we know what u is now, so we can actually write this in here as 1/2 x minus pi over 4 is equal to both pi over 3 and 2 pi over 3. There's two solutions for this thing, and we can multiply through by 2. So at this point it's getting pretty ugly because the next step is going to be to add pi over 4, and we got things in thirds, so let's get everything in terms of twelfths. Let's see, I had to multiply by 4, so this next one is actually 16 pi over 12. Divide both by 4, we get 4 over 3. Okay, that looks good. And then finally we can add on to x, that 3 pi over 12, so we're going to have 11 pi over 12, and tacking on a 3, 19 pi over 12. So this should refer us back over here. 11 pi over 12, that's oh so close to pi, and if we look at this point here, that's oh so close to pi. So actually that looks like that's the 11 pi over 12. And 19 pi over 12, that's bigger than 18 pi over 12, which is 1.5, so it should be past that mark, so that's got to be the 19 pi over 12. So we have those, but we also have these further along, and how far away are they? Well, that is 1 period, which is 4 pi. So we're ready to write our final solution here. So we're going to have both the ones on the upswing, which is these. So that's x equals 11 pi over 12 plus the period, so not 2 pi n, but 4 pi n. And then the downswing ones, 19 pi over 12 plus that period, 4 pi n. And remember, n is an integer. Okay, a lot to that one. Thanks for watching. Character and Scholarship for Life.